Machine learning for dummies. So today we're gonna learn how to do heart disease detection. This project requires a little bit of Python knowledge. However, if you are a beginner, you don't need to understand every single line of code. In this case, you can copy the code and ask ChatGPT to explain it line by line. The most important thing is you understand the logic behind it and the steps how to solve the problem. Some key to take away is you can make a checklist before the project to make sure you go through all the important steps. So this looks like a lot to comprehend. Actually, I don't remember exactly what is the syntax of it. I just remember some keyword. Like I know that I have to use a function from sklearn and maybe I need to do reprocessing. So I just type like a few character and I can choose from the list. So I hope this gonna help you find it easier to import the libraries. And also I don't write all down in first. When I try to use a function, if I haven't imported yet, only then I starting to add it in. So this is my checklist for the project. Normally every single machine learning project, I will go through one by one in order. So first of all, we need to select a dataset. So I name this dataset as df, which is data frame, but you can name it whatever you want. And then I use panda read CSV to import the data. To see the first few rows of the dataset, I use .head. It will show us the first 5 rows. When I'm looking at this, I will try to understand the name of each columns. What is it about? Blood pressure. First of all, I will do a little bit of research to see what is the background, to do a little research to know more about the meaning of all these definitions. So I could understand the dataset better, and that can help with my training process. If I use the .info functions, I will know how many rows and how many columns there is. So there are total 1061 rows and total of 12 columns. One thing that I can pick up from this table is there is a mixture of integer and strings, so we know that later on we have to process all the string attributes because computer couldn't understand text, so we need to somehow turn it into whether numbers, binary, or boolean. Next we're gonna use describe. So you can see the minimum number of resting blood pressure and cholesterol is 0, which is kind of unusual because nobody have 0 blood pressure or cholesterol. In this case, we need to do a little bit of checking and cleaning for the data for resting blood pressure and cholesterol. For fasting blood pressure, we have minimum 0 and maximum is 1, so I know it's binary. For the age, the minimum age is 28, maximum age 77. That's normal. XHR, OPIC, heart disease seems normal to me. So now let's move on. We're gonna check if any cell in this data is empty. Luckily, there is no empty cell, so we can move on. I will remove the duplicate rows if any. Remember we mentioned there are 2 types, numerical and categorical. Now I'm gonna put all the column that is category into this object named categorical. This is to organize it so we can do the cleaning, the transformation, and the processing much easier. I'm curious like how many people have it and is there any difference between patient with heart disease and non-heart disease. So I'm going to create a figures and inside a big figure have many subfigures. We're gonna like calculate how many of them in each category. Example, if we look at a sex figure, we're gonna see there are 725 male and 193 females. So there's a lot of interesting information we can pick up just by looking at this figure. For example, a lot of people have chest pain type of ASY. That is interesting. Is this gonna relate to heart disease? We can find it out later on. So one thing that we know It is much easier to train a model if we have a balanced dataset. In case it is imbalanced, we have to do a few extra steps. Heart disease and non-heart disease is quite balanced. We don't need to do such things. So now I already have a sense of the data, but because our target is to detect heart disease, so now I want to put a side-by-side comparison between heart disease and non-heart disease. Looking at this figure, we can see that a lot of males have heart disease compared to female, and people that have chest pain type of ASY have higher chance to have heart disease compared to normal people. Also, exercise gene, yes, and flat XD slope. Very interesting, right? So I already pick up a few things. Next, we need to verify if our assumptions is correct or not. Now, I'm gonna do a deeper cleaning of the data. Before this, we already removed duplicates, but we haven't touched the unusual point, which is resting blood pressure and cholesterol with zero value. So now I'm gonna count how many there are. For resting blood pressure, there is only one row. And for cholesterol, there are 172 rows. If it's only one row, I can just remove it. But 172 is around 10% of the dataset. We're gonna use another technique, which is replace the zero value with median. However, one thing to notice, I wonder, can we just put median for all the zero values? But if we think about it, we have heart disease and non-heart disease, so probably the cholesterol for each type is gonna be different. In this case, I will come with a solution that I'm gonna put median of heart disease for the zero values of the same category. Okay, so this line is to copy the dataset. This is the best practice, so we can keep the original dataset intact in case we want to go back to it later on. Next, I'm gonna just remove the resting blood pressure. There is only one row, and for the cholesterol, I'm gonna divide it into heart disease and non-heart disease, and then I'm gonna replace it with its median. After that, I'll do a little bit of recheck. So now I can see the minimum value has changed. I think we already got it right. So let's move on to the next step. Remember we talked about numerical and categorical. So right now we have to handle the categorical by using a technique called get dummies. So this is to transform categorical values into Boolean. Example, we have like 4 chest pain types. We're gonna put like false, 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 and the one that doesn't mention is gonna be true. So now our computer can understand which chest pain type it is. After transforming the data, I want to see the relationship between each others so I can know which one could impact others the most, so I can identify which filters to train the model. For this purpose, I use correlations heat map. The darker it gets, the more important it is. But this is a lot to comprehend, so I want to filter it out, only choose the most important ones. I'll play around with the number. I try replace this with 0.2, 0.5, but turn out 0.3 is the best one for me because if it's 0.2, it's too many of them, and if it's 0.4, it's too few of them. You can see here, only a few features left. I'm gonna pick and use this feature for the model training. Finally, we reach to the stage of machine learning. The first step is we need to split the data. So I'm gonna split the data into two parts, 80% and 20%. The 80% is to train and 20% is to test. You can play around with a number, maybe 85-15, 70-30, but I suggest 80-20. Now, we have to think about a model that we are going to choose. So you need to classify patients that have higher chance of having heart disease. So it should be a classification machine learning model. There are also logistic regression and a few more, but this case, I'm gonna go with KNN. I have no clue what would be the result, so I try many different ways and just try to get a higher accuracy rate. First of all, what I did is I trained data by each feature so I could know which features is more important than the rest. Then I trained it all together. We have accuracy of 80%. I also train with some of the features removed, and then I take all the accuracy percentage and compare to each other. So we have 80% and 85%. It seems like the methods of training with some of the feature removed have higher rate of accuracy. I'm quite satisfied with this result, so I'm gonna continue to evaluate it by using confusion metric. So you true negative, false negative, so you have a better understanding of the accuracy, sensitivity, and precision. If you're already happy with the result, you can stop here. But if you want to optimize, you could try with another machine learning model. For me, I want to try with XGBoost. It's a very advanced machine learning model with a lot of parameters so you can play around with the numbers. So the steps are the same. We're going to split the data, feed the data, going to train and test and evaluate. For this one, with the default setting, I have 84%, which is quite good, almost 85%, same as KNN. One thing about XGBoost I see here is they have a lot of parameters. So I want to manually tune it a little bit, play around with the parameters to see if I can push the accuracy a little bit higher. So after many tests and trials, I'm able to get 88%, which is the highest number in this project. I also do the feature importance so I can see which feature impact the result the most. And as you can see here, cholesterol play a very important role. And that's all. I hope you enjoy this project.